Inferential statistics can answer questions like: inferential statistics is a branch of statistics that allows researchers to make conclusions about a population based on data from a sample. Unlike descriptive statistics, which summarize and describe data, inferential statistics goes a step further by using sample data to infer or generalize findings about a larger group. It helps in testing hypotheses, making predictions, and estimating population parameters when only a small portion of the population is studied. The backbone of inferential statistics is descriptive statistics, as it uses measures such as means, variances, and distributions derived from the sample to draw broader conclusions. Here are 10 example questions related to Master in Educational Management (MEM) that could be answered using inferential statistics. Is there a significant difference in the leadership effectiveness scores of male and female school administrators? Is there a significant relationship between teacher professional development and student academic performance in public schools? Is there a significant difference in the job satisfaction levels of teachers who use technology in the classroom and those who do not? Is there a significant difference in the levels of motivation between students in traditional classroom settings and students in online learning environments? Is there a significant difference in the average teaching performance ratings between teachers with advanced degrees and those with undergraduate degrees? Is there a significant correlation between the availability of school resources and student success rates in state exams? Is there a significant difference in the perceptions of school climate among teachers from urban schools versus rural schools? Is there a significant relationship between school leadership style, authoritative, participative, etc., and teacher retention rates? Is there a significant difference in the dropout rates between schools with higher parental involvement and those with lower parental involvement? Is there a significant difference in the academic achievement of students participating in extracurricular activities versus those who do not? These questions can be addressed using inferential statistics, such as t-tests, chi-square tests, correlation analysis, or ANOVA, to draw conclusions based on sample data and generalize the findings to a larger population. Application in Educational Management (MEM). In Educational Management (MEM), the application of inferential statistics plays a crucial role in enhancing decision-making processes by providing a scientific basis for conclusions drawn from sample data. One of the primary advantages of inferential statistics is its ability to generalize findings from a sample to a larger population. This is particularly valuable in educational settings, where it is often impractical or too costly to gather data from every student or teacher. By using inferential statistics, school leaders can make evidence-based decisions about various aspects of education, such as curriculum effectiveness, teaching strategies, or school policy changes. For example, educational leaders can use inferential statistics to assess the effectiveness of a new teaching method by comparing the academic performance of students before and after the intervention. This allows for objective conclusions about whether the teaching method leads to significant improvements in student learning. Similarly, inferential statistics can help identify the impact of new educational programs or reforms by comparing performance data across different student groups or school settings. Leaders may also use inferential techniques to evaluate how school climate, teacher professional development, or parental involvement affects student achievement, thereby refining policies and strategies to improve school performance. Moreover, inferential statistics enables the testing of educational hypotheses, allowing school leaders to validate assumptions and make informed decisions. For instance, a hypothesis could be tested to determine whether there is a significant relationship between school leadership style and teacher retention. Statistical tests, such as t-tests, ANOVA, or regression analysis, provide a rigorous framework for answering such questions, which can lead to more targeted and effective school leadership practices. However, while inferential statistics provides valuable insights, educational leaders must exercise caution and be mindful of its limitations. Sampling error is a critical concern, as the sample may not accurately represent the broader population, leading to flawed generalizations. For example, if a school sample is not representative of the diverse student body in a district, the conclusions drawn may not apply to the entire student population. To mitigate this risk, leaders must ensure that samples are adequately randomized and reflective of the population they seek to understand. Another potential disadvantage is the misinterpretation of data, which can occur if the statistical techniques are applied incorrectly or if the results are not carefully analyzed. For instance, inferential statistics may show a statistically significant result, but this does not necessarily imply a practical or meaningful effect in real-world terms. Educational leaders should be aware of the distinction between statistical significance and practical significance and ensure that their conclusions are grounded in the context of the educational environment. Additionally, Inferential statistics often relies on certain assumptions, such as the normal distribution of data or the independence of samples. When these assumptions are violated, the results of statistical tests may be unreliable. For example, if the data is skewed or if there is a dependency between sample groups, e.g., students from the same class or school, the inferences made from the analysis may not be valid. Therefore, educational managers need to be diligent in checking the assumptions before proceeding with statistical analyses and, when necessary, use appropriate alternative methods or transformations. Despite these challenges, when applied properly, inferential statistics can significantly enhance educational management by providing objective, data-driven insights into the effectiveness of educational practices. By adopting a critical and informed approach to data analysis, educational leaders can make decisions that improve student outcomes, optimize resource allocation, and foster a more effective educational environment. Properly applying inferential statistics ensures that educational strategies are not based on intuition or anecdotal evidence but are grounded in rigorous, empirical data, ultimately leading to more effective and sustainable changes in education.